Hello everyone. In this video, I will talk a bit about how to repair or replace the electronic components of drone systems. First of all, the electronic components of drone systems are quite complex structures, especially flight control boards, remote control receivers and transmitters, video transmitters, and OSD units are devices that are quite complex and have sensitive sensors, making them very difficult to repair, because it is very difficult to determine what caused the error. If a PCB circuit is burnt, you probably cannot reuse that circuit. If you have a burned capacitor or resistor, meaning the circuit components on the electronic parts have failed, you will need high-tech electrical laboratories and electronic labs to replace them. Because PCBs are devices that can be affected by static electricity, your protective equipment, magnifiers and lighting need to be very good. There may be places where you need to use liquid solder. You might also need to use micro tweezers. There may be places where you need to use liquid solder. You may need to use micro tweezers. But generally, how are faults detected and how are they replaced and repaired? What is the procedure here? Let me talk about them. Now let's start with our batteries. Now lipopolymer batteries, as we mentioned in our previous videos, have a total of 3 wires. Actually, we have 2 connectors. The first connector's values change according to its size. For example, the battery you see here is an XT60. It's made up of a plug. This is the name of this connector, its model. These can also be XT90 plugs, meaning they can be larger. It could also be an XT30 plug. The 30, 60, 90, or 120, or 10, the XT10s, these completely change according to the size of the connector here. Why is this important? When you want to connect this connector to the power circuit of the drone, you should choose the assembly. You'll do on the drone's power circuit according to the size of this connector. Otherwise, they won't be compatible with each other. From the connector you see here, we get the voltage data from the cells inside the battery. Why is this important? Now, by obtaining the voltage data from our batteries, we can determine the health of the battery. At the same time, I will show you how this is done shortly. Is there any deformation on the outside of the battery? For example, this is not a battery that came from a crash current. But if there is a battery that came from a crash current, if there are dents at the corners, any swelling in the cells inside, or any visible swelling on the outside, your battery definitely should be replaced. Batteries can have dents or cell damage. Swelling might be visible. Damaged cells or deterioration need replacement. It is possible for the battery to have any swelling when viewed from the outside. In battery technologies, if there is any damage or malfunction in the cells inside or in the casing you see here, it needs to be replaced. Because intervening inside the batteries is quite dangerous, and replacing them instead of trying to repair them is much more reliable. Because intervening inside the batteries is quite dangerous, and replacing them instead of trying to repair them is much more reliable. Now let's first talk about the cell structure of the battery. This is a 1-cell battery that you see here. And what you see here is a 4-cell battery. In short, this battery contains 4 of the larger ones inside it. As you can see, this one also has 2 power cables. And you can get the cell voltage values from the 2 metal plates you see here. From the cell voltages here, you can calculate how many volts this is. One battery. A healthy battery should be at minimum voltage and maximum voltage. Of course, we are talking about these for LiPo batteries. There are also high voltage versions of LiPos, meaning high voltage versions. These are used in drones to achieve longer flight times. These can go up to a certain voltage. So how do we measure the voltages of a battery between the cells? We have a multimeter that we introduced in our previous videos. In our multimeter, here, we have an arrow. We convert this to DC voltage. So why are we switching to DC? Because our batteries operate on DC voltage. AC voltage is more like the grid voltage. DC voltage is the energy that we can store with our batteries. Similarly, just for general knowledge, DC voltage can also be obtained from solar energy. Now we have a shoe that we can connect. One of them is black and the other one is red. And when you look at the connector structure, you'll see a black wire next to the red wires in the connector. This black wire is our ground, or GND. After we connect this black shoe to our black ground point here, we connect the red shoe to the other ends of the connector between the cells. Right now, the value I'm seeing is approximately for the first cell. After we connect our black shoe here to the black ground point, we connect the red shoe to the other ends of the connector between the cells. The value I'm seeing right now is approximately for the first cell. If you shift the shoes 1 step to the right, you can detect the second cell. This is the value I'm seeing. If you shift them 1 step, you can find the third cell. you can find the cell 392. When I shift them one step, in short, my highest value and my lowest value have a tolerable value in between. We see that the energy of our plane is quite low. We need to connect the charger here to make the flight. Now, generally each cell normally has a voltage, so we do it with 4s times 4 times 3.7. At its maximum, you would do it with 4 times 4.2. There is a voltage of volts here, so your maximum should be in volts. How can you detect this? You can detect the battery's charge level like this. We're holding our connector in black again. We're holding it to the ground, and we connect our red shoe to the cell at the very end. This time, you will see the total of all our cells from here. So in short, you can also determine the charge level of our battery this way. You can also determine whether the batteries are faulty using this method. So, first you will make an observation from the outside. If there is no swelling, no dents or breaks, you will detect the intercell voltage. Now let's move on to the motors. Our motors have just arrived. You wanted to turn it in your hand? Yes. You noticed that it didn't turn, or you heard a sound while turning the motor. These are very possible because our motors are open at the top to allow air to enter, and they are sourced from Harun. A foreign object can get inside. First of all, we will remove the screws under our motor using this small screw. You see here, I removed the screws under this motor. After you remove it, there is a shoe in the middle of the motor. Compression tool. The main purpose of the compression tool here is to keep the shaft steady. They put this on to keep the shaft steady. You need to carefully pull this out from here after you remove it, because it has a strong magnet. You can also separate this by pulling it out from here. Now let's first take a look at the rotor side. The rotor we refer to in the motors is the moving part. There is a shaft in the middle, and as you can see around it, there is a group of magnets. I can show you that it's a magnet like this. Now I don't see any foreign objects or faults on these magnets. There is no darkening at all. So I can say that these magnets are solid. I'm moving on to the winding section. In the winding section, there is again a space in the middle where the shaft goes in, and around the edges, I have copper windings. These copper windings become magnetized after being electrically charged, and therefore when they become magnetized, they interact with the fixed magnetization, creating a rotational movement here. I can't turn this around, because this is my stator, but this is the rotating part. Now, since these are the windings you see inside, it's not very possible to check them. Therefore, after visually inspecting, you can still perform voltage tests on the wires of these motors. However, since repairing them is not very feasible, especially in cases of burning, I recommend that you replace them. Therefore, after visual inspection, you can perform voltage tests on the cables of these motors. However, since repairing them is not very feasible, especially in cases of burning, I recommend that you replace them. When do you consider repairing them? If a foreign object has gotten inside, you can take it out and clean the dust off. You can also do this with a slightly damp cloth. After that, make sure that the inside is dry. You can also do this with a slightly damp cloth. After that, make sure that the inside is dry. Reattach carefully. Test motor with PWM. Be careful when attaching it, because after putting on the screws and the compression fitting, which can be tight due to the lack of lubrication, your motor will be ready to use again. After you repair your motor, don't forget to check it with a PWM generator, our signal generator, before connecting it to the drone. Let's take a look at our ESCs. Now what you see here is the closed state of an ESC. This is an ESC rated for about 60 amps. Our ESCs consist of 6 wires. As we mentioned in our previous videos, 3 wires go to the motor, 2 wires here go to the battery, and 1 wire goes to our signal wire that connects to the flight control board. Now, this is a burned ESC. As you can see, our sleeves here, when they separate from the motor, cause something like this. It caused the sleeves to melt. This part here has probably melted due to drawing too much current, or I can mention the age of the ESC. Also, the outer sleeve, the large outer sleeve, is worn out. This could likely be due to a crash. The internal structure of the ESC is a PCB circuit like this. Now here you can see our MOSFETs. We also have our capacitors. These capacitors are not SMD type capacitors, meaning they are not mounted directly on the PCB, so we call them THD type capacitors. It's possible for us to change these, but here you see a double layer circuit. In fact, this is probably a 4-story circuit. Because it's a 4-layer circuit, it's very difficult to intervene between them. In short, since it would be much more costly to have it repaired, or if there is a fault in our ESC because it would be much more costly to repair it, It is much more reasonable to replace it if you have not been able to detect it, or if the fault in the drone is caused by the ESC. We've reached the end of our video. Thank you very much. In the next stages, we will continue with these videos within the scope of our conversation.